What is up guys, it's Peter from Group 21. This is my demo about what I have done so far for the final project. I'm currently working on an ELF parser for our operating system in order to be able to execute ELF files. From my last presentation, I was going to implement ASLR, or Address Space Layout Randomization, as the main theme for this project. However, I changed my mind midway through Project 4 because dealing with virtual memories has been horrible. So I came to our TA Mansoor for ideas, and he suggested writing an ELF parser. The main reason is that we are only loading and executing the bin file into virtual memory for Lab 4. Nowadays, in a real-life OS, we actually won't be working with bin files that much. It's a standard for Linux to execute ELF files, and that's why our operating system should do the same. I thought that it would be a cool idea since I wanted to learn how ELF works too, and here we are. If you are like me when I first approached this idea, you're probably wondering, what is an ELF file and how can we execute it? Then I just look it up on Wikipedia. ELF stands for executable and linkable format. And I'm going to try and explain this file type according to what I have learned so far. Okay, so an ELF file is divided into different components, but most important is the file header, the header table, and the section table. The file header is the very first 64-bit of the file, which store information such as if this file is 64-bit or 32-bit format, little or big endian, target OS type, and so on. But the most important info here is the offset of the header table and section table, which can help us locate these next two structures. So I get started parsing. As you can see, it was really similar to what we did for the file system. I created a struct for the file header, read the raw bytes in, and manually translate bytes into U8, U16, U32, and U64. I could have used transmute, but I prefer not to use unsafe code. From the file header, we now know the offset of the header table from the beginning of the file. So, the header table is the spiciest part of the ELF file in my opinion. This table entries store information, helping the OS to construct the process image. The most important things in here are the offset and the size of the segment in the file image. Let's say this segment is our binary code. The offset can be something like 10,000 and the code size is 6900. We can use this information from the header table entry to read them into a byte array and then map it into the virtual space in our process.rs. The file header already specifies where in virtual memory we need to load this image in. So after we load this segment there, we can hopefully execute it. On the way of implementing the parser, I used some Linux command to help me check my parsing. I thought it would be fun to implement them too for our RustOS. readf/h on Linux gives us information about the file header, and this is what I have on my OS when I run my own parser. When I have time after this week, I'm integrating this feature into our shell, so we can actually execute readf just like on Linux. To demo that I actually can execute ELF files on my OS, I've created a new load function in process.rs to load the ELF file, parse it, and put the binary into the virtual memory accordingly. After that, I just let it run like phase 4 for our last project. As you can see, the ELF files execute normally just like when we load the bin files in our project 4. At this point, we can execute any ELF file that is generated without dynamic linking. Now that I got the parser working, I'm looking into implementing ASLR for our current OS. ASLR is Address Space Layout Randomization. It's basically throwing our process page and stack page around on the virtual address space in a random manner every time we boot. So how do I get something random? Well, we already got the timer working, so I can use the current time after the OS is done, initializing allocator, file system, RQ handler, and MMU as my random seed. This time is random through boot, and we can check it just through a quick print line. As you can see, this number is randomly different every time we run, so it can be a good seed to generate random number. We can use modulo arithmetic to get our random number when implement R&D core for our random number generator. I haven't fully implemented ASLR yet, but I'm hoping to get a randomized index for each process, put the code segment at page size times index away from user image base, and do the same thing for the stack. This only works because our fib code is small, and it can all fit into one page in memory. For longer files without PIC or position-independent code, it will be harder to ensure execution after we randomly move the code segment. This is all that I have done for the final project after being done with Lab 4. I really appreciate you guys watching this. And if you like it, please give it a like, comment, or subscribe. Thank you.